Right, now let's look at this idea, this beautiful concept, the concept of reduction formula. What do we use it for? Look, after looking at integration by parts, you kind of start to see that if I have, for example, the integral of x squared e to the x, let me say, x squared e to the x dx. Here, we know that, like we said, whenever you have an algebraic term, then in any case, you're going to make u the algebraic term, unless you are having it multiply a logarithmic to say x squared ln x, right? But anywhere else, it is the u, the algebraic. Whether it's multiplying, whether you now have it multiplying a trig function like sine x or whatever, it is the u. And because it's the u, you're going to find du dx, and then you're going to have to differentiate, to integrate by parts. And what you're going to see is that you would need to integrate by parts twice if this thing has a power of 2. And if this thing has a power of 3, you're going to need to integrate by parts 3 times. If it has a power of 4, you need to integrate by parts 4 times to get to your answer. And we find out that if we have a very big power, we could take a really, really long time just integrating. If you have the integral of x to the 8 sine 3x, can you imagine? You'd have to integrate 8 times, integrate by parts 8 times until you get your final answer. That would be really, 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 really stressful. So, and time consuming. So what we'd say is we have a way of reducing this, okay? We still have a condition where it would be integration by parts, but then we have a formula that we can use that helps us arrive at our answer. And you'd have to remember this formula. But remember, we'll just have about 4 cases, okay? Only 4 cases to remember, and you'll be fine, all right? So you have to remember the formula, though. You'd have to be good at memorizing, because you'd have to memorize. And in some cases, you could be asked to show where the formula came from, and you'd have to use the integration by parts knowledge. Okay, so here we'll start with case 1, and we'll see where the reduction formula came from and what it is for this case 1. And you just have to remember, if I see anything like this, then I'm going to use. What is case 1? Case 1, you have the product of a polynomial function and an exponential function. And what we care about is the u. And here, the u will be of course, it will be the polynomial, the algebraic term. So here, that algebraic term is raised to a large power. So that means it's going to make us integrate by parts many times. But hey, we are finding out a formula that would make the job easier for us. So we have the integral of x to the n, where n is some large power, some power here, multiplying e to the x with respect to x. What are we going to do? What is the reduction formula if we have anything of that form? Okay, what is the reduction? Oh, so now to determine it, we use the idea of integration by parts. So let's determine it. Let's find it, and then we can memorize all of them at the end. Let's find out how we would get to it. It would be e to the integral of x to the n, e to the x dx. Of course, we know that we are going to say let u be equal to x to the n, whatever power of n will be, because it's the algebraic term and is the one that gets to be u, all right? Now that means du dx will be equal to n x to the n minus 1, okay? And the power reduced, that we multiply, this is like the power rule, if you remember. We would have the coefficient of x being multiplied by n, and that's n times 1, that's just n to the power of n minus 1, the power reduces by 1, right? All right, and here that would mean that my du would be equal to nx to the n minus 1 dx, right? Now, I'd say, what is my dv? Remember, integration by parts says u is the integral of u dv is equal to uv minus integral of v du. Okay, this matters to remember that. Right? How do you remember that? You know you are always going to look for u, so it's u dv first, and then at the end it's v du. In the middle it's just uv minus v du. So what is dv now? We need to find dv. dv would be the e to the x, and that would mean v is the integral of e to the x with respect to x. Well, the integral of e to the x is just e to the x, so v would be e to the x, okay? Because the derivative of e to the x is just e to the x. That's as long as it's just e to the x, not e to the 2x, or e. If it's e to the 2x, it would be different, but it's just e to the x here. So now, we would therefore say, okay, that means that my answer, the integral that you want, of x to the n e to the x with respect to x would therefore be equal to uv. What is u? It's x to the n multiplying v, which is x to the e to the x, minus the integral of v. What is v? It's e to the x. Du. What is du? It's nx to the n minus 1 with respect to x. Right? Wow. So what are we going to say now? The integral of x to the n e to the x with respect to x will be therefore equal to x to the n e to the x minus, we can pull out the constant. This n is just a number, so it's a constant. So minus n comes out. We now have we now have x to the n minus 1 e to the x, and this is with respect to x. Wow. And we can bring in now the idea of reduction formula. We have kind of like arrived, okay, at what we care about here. Now, the reduction formula we like to use a certain symbol that makes it easy for us, okay? And that symbol is, we would say, the integral, whatever integral you had at first that you're looking for, so it's x to the n e to the x with respect to x, we would call it the integral with n, because to the n, in, because n is just that power, right? That power that will be here. And if you see, if we now have the integral of x to the n minus 1, if the n reduces by 1, of course e to the x won't change the x. It's now in minus 1, okay? Because where there was n, we are now putting n minus 1. And if you look here, that's kind of what we had. Here we had x to the n e to the x. Here we have x to the n minus 1 e to the x. So this is the in minus 1 thing. That integral, I is integral of something, integral of the nth, whatever that nth function here, which here would be the algebraic raised to the power of n. So it will be having an integral sign. That's why it's I, okay? That's why it's in, all right? So here, if I want to then write this reduction formula, I would therefore say the integral of here, the integral of this is just in. So I would therefore say in is equal to, but you would have said let this be in, okay? Let this be in, and that would mean that this would be in minus 1. The integral you had, okay? So that means here where there's the integral we are now replacing with in is equal to, what is it equal to? X to the n e to the x minus n multiplying the integral of this thing with in minus 1. We said we call it I of n minus 1. And this is the reduction formula for something that has the form x to the n e to the x, okay? Where you are raising your polynomial, all right? And so if I am to get a question, which I'll solve in the next video, okay? We'll just solve the question of this form in the next video, and we'll see how we'd find our answer. So remember, when we have x to the n e to the x, that's our reduction formula would look something like this. X to the n e to the x, okay? Which is what we had inside. It just comes here. And then we have the negative n multiplying in minus 1. Fine, this is very simple, very, very simple and easy to